we doing? We working? No, we're working, yeah. Hey, good morning, everybody. Nice to see you all here. I was sitting there, I was thinking our very first OpenPOWER Summit. I think we were in a closet with like a little stool to stand on for a stage. It was, this is great. I mean, you guys did a really nice job. So I'm not going, I don't even feel worthy to stand up here. I'll give it a shot. All right. Okay, we'll go on up here. I like it better down there, but closer. But it's nice up here. This is nice. Okay. Yeah, and one other thing I wanted to do is there is a great friend and one of the people that was really instrumental to getting OpenPOWER started. I happened to see him skinking around. Where's Gordon at? I wanted to just at least give a shout out to Gordon. Our first chairman of OpenPOWER, he emerged from retirement somewhere in the North Woods of Canada and came here to see us, and it's great to see you, Gordon, so thanks for coming. So what are we going to talk about here today? Actually, today, I wanted to talk about a few things, and actually most of them are things that I've talked about before. In some ways, it's a bit of a retrospective on OpenPOWER, and you know, what do we set out to do? How does it evolve? How has it changed over time? And where are we at now? This chart on the left up there, you know, the classic Moore's Law chart, it's actually a chart that I first showed in 2011 at a packaging keynote. That then, you know, Gordon, who I mentioned, and I actually refined and shaped over time. It was really to answer the question of why are we doing OpenPOWER? It's a problem statement. You could see what it is the y-axis of the chart on the left there is price performance. And, you know, and as technologies and processors cease to provide that cost performance improvement, you got to go find something else to fill in the gap. You got to go find something to fill in the gap. And that's what most of the industry is working on right now. And right now, you know, I would argue, you know, we've put a lot of things in there to fill that gap. You know, the first thing, you know, I always say that we've put in to fill the gap, you know, is virtualization, right? You know, it's a way to improve cost performance of a system by about 5 times, but you take it from 10% utilization to 50 or 60% utilization. Don't need a new microprocessor, don't need anything else, and voila, you got a 5x cost performance improvement. That's one of the biggest gap fillers. The problem is once you virtualize, you're done. You know, it doesn't scale year after year. You know, you can virtualize once, then you're done. Then you got to go find something else. And I would argue that the biggest gap filler between, you know, what most of the industry is plumbed on and working on the Moore's Law and where technology and processors are taking us today, the biggest gap filler we see going forward is acceleration and putting accelerators into systems. I think that's a pretty solid trend. You know, on the right side, you know, on the consumption models, I think everybody knows those. But the biggest one, and the one that's having the biggest impact on us now, is cognitive computing. And cognitive computing is just driving consumption up like crazy. You know, so I got on the left, you know, that we have, you know, a diminishing of what's been providing cost performance improvement is coming on in the industry at the same time the consumption's going up. It was kind of funny. I'm going to throw this chart up here. It was kind of funny. I've been telling this for quite a while. And then just yesterday, this is a snapshot. Sumit Gupta, one of our original OpenPOWER members, he actually was part of Nvidia, and now he's part of IBM. But he sent this to me yesterday. He said, "Hey, Brad, you know, you got a little validation. This is actually Dave Patterson's chart. You can actually tell it's Dave Patterson's chart because it shows that the most improvement is due to RISC processors." It's like you look at it and you say, "Oh, yeah, of course that's a Dave Patterson chart." But you know, he was just showing this week, and actually I find that to be the case, right? We were talking about this, you know, in 2013, 2012, quite a bit. I think the industry's moving, and everybody's really realizing that these are the pressures that we're faced with. And what Sumit told me was after Patterson showed this chart, his next chart was, yep, the answer is accelerated computing. There's a lot of versions of this chart out here, but this is just an example, right? You know, as you sit there and you say, you're being pressured and you're being pressured, it's harder and harder and harder to continue that improvement and show that cost performance improvement. You know, this is what's happening in the market. And you know, this is, there's a lot of versions of this prediction, but this is, you know, how the total addressable market is growing. You know, it's been on a pretty steady 5% CAGR for forever, and that we've all been measuring. And we're seeing this exponential take off, which is really the new markets that are defined by artificial intelligence. And that's just taken off and going like crazy. You know, one of the most interesting things about this particular piece of that conversation, though, is all that stuff in white, right, that all of us in this room have been doing for the previous years. You know, the biggest workload down there in the white section, of course, is database, but it's all process automation. And when you approach somebody and say, hey, you know, let's go, you know, let me give you some IT, let me sell you some computing, let me sell you some software, all that you can really do, right, is save them money. So if they're spending $5 on a process, you know what, I'll get it done for 4 for you. Spending $7, I'll get it done for 6. The green part's really, really different. The green part is different in nature. Now, what's happening in the green part, which is why it's taken off exponentially, is you go to them and you say, hey, I got artificial intelligence for you. Now your company can make $10 more. You were making 5, I'll get you to 10. You know, you're trying to service your clients and figure out when they need to get a service done, or trying to figure out when you can go and buy something or sell something. I'll figure that out for you better, faster, stronger, and you'll make money off it. Now you go from being an automation and a way to save money to one of a competitive advantage. And that is why demand for IT in that space is going to take off like this. It's different in nature. So this is another chart, which is like one of the very first charts. This is actually a chart that Brian Talek, our current president, made for me when we very first started OpenPOWER. And it tells an interesting story, very much along the lines of the one that I told you the narrative for. This is the chart we made to answer the question, well, what is OpenPOWER? And we made it back in 2012, 2013. You know, and a lot of this has been alluded to, right? The top left-hand corner is the open firmware stack. You know, we said OpenPOWER is open, we're going to make everything open. And actually, that really took off. That's been a very good success story for OpenPOWER. As we created the OpenBMC and that open firmware stack, we're now actually seeing the rest of the industry come and get onto that stack. As a matter of fact, there's a group, you know, that involves Intel, Microsoft, Google, IBM, all taking our OpenBMC, standardizing on it, and making it part of the Open Linux Foundation. That's a great thing. We went and moved the needle in the industry to a more open firmware stack that now we got everybody working on. That's the kind of thing that we set out to do, because this is all about making the plumbing much more ubiquitous and easy to get to. And of course, you know, you got the operating environment software stacks. We got a lot of them up and running on the platform, a lot of them optimized on the platform. But the interesting part of the story that's down on the bottom is when we started. When I first started OpenPOWER with a lot of the people in this room, everybody was going to become a microprocessor designer. It was great. Everybody was like, are you really going to take the Power IP and let me take it and go build microprocessors? And I said, knock yourself out. We'll do that. And wow, really? Yeah. You know, and then you realize it costs about $250 or $300 million to do that. And it's like, oh, that's not quite so exciting. But something else happened. But, you know, something else happened and something else changed. What also happened is accelerated computing happened all at the same time. But if you think about it, right, this is the really interesting shift that occurred in the industry as we were going along. As you think about it, as you went into the accelerated computing, right? Now, what's the average accelerated computer? Well, the most easy one to point to is a deep learning training platform. We have one, the AC922, but there's many of them out there, a processor and 4 GPUs. Well, what is that? Well, a processor these days is about 700 square millimeters of silicon, state-of-the-art silicon. GPU, 700 square millimeters of state-of-the-art silicon. 4 of those, man, you're staring at, you know, 30,000 square millimeters of silicon just to do one solution. Are we going to integrate all that, put it on a chip, and ship it out? No. Technology is not scaling as fast. So what really is happening is this. Oh, there it is. Yeah. What's really is happening is this, is people are really wanting to optimize their architectures around accelerated computing. And now it's becoming, what are you doing to open up your interfaces, give me the performance I need, give me the technology I need to go and attach what I want to attach to the processor in an open way, at my convenience, on my terms. And that's really the detour that we took. And you know, part of the offshoot of the OpenPOWER ecosystem is the OpenCAPI ecosystem. But this is strategic. This is where the industry's going. This is where the future of IT is. And it's going to actually redefine and reshape what the architecture of systems is going to be. And you can see we're attaching everything to it. That top path still exists. It's still part of OpenPOWER. And anybody who wants to become a microprocessor designer, see me after class, and we're going to go and we'll set you up. But bring a wheelbarrow full of money. You know, it costs a lot of money. But that path is still there. We're still available to people. But it's not the big differentiator. It's not the big differentiator. I don't think you're going to be able to take over the world, you know, being able to do it, trying to do it all on one piece of a super SoC. So this is the shift in the industry. This is the big shift that's taking place in the industry right here. Cores and caches and system buses used to be the differentiator. That used to be the way that everything changed, and that's where all the value sat. Now, oh, by the way, the I/O, that was plumbing, right? You know, north bridges, south bridges, whatever you want to call them, that used to be plumbing. Now that's the differentiator. That's where the technology and the value is going to come from. Is from the I/O attach and the memory attach, and cores and caches are going to really become the plumbing. And this is a shift that's taking place in the industry, and this is a shift that we're leading with OpenPOWER and with our partners in OpenPOWER. If you go and you look, right, you know, the system bottleneck now is very likely going to be, you know, an I/O bus. You know, if we look at a lot of today's architecture, if you're dangling off a PCIe Gen 3, that's very likely to be your solution bottleneck now. And now if you go and look at where we're at today, Hugh mentioned, you know, Power 9, you know, we're doing 7 to 10x that bandwidth, especially out to our Nvidia GPUs using NVLink that we started as one of our first OpenPOWER projects with Nvidia. You know, and Nvidia is exactly, I think, a great example of a group that saw the trends and what happened in that fork in the road that I saw. They identified it early and invested heavily against it, and they're reaping a lot of benefits from it. And to that end, I'm going to actually ask Jerry to come up and join me from Nvidia to say a few words about the investments they made. Jerry's a little bit unique in Nvidia. He's been there since it was a 600-person company. He joined in 2000, and he's watched all the trends and all the investment that Nvidia has made to get out ahead of the trends and the curves that I'm describing here. And so, Jerry, why don't you go ahead and share a few words with everybody about your journey over Nvidia.
Yeah, I'd love to. Thanks, Brad. It's a pleasure being here with all of you. So you know, I've been on this path for a long time, of course, and we definitely have a shared vision. And recently, we've definitely been seeing a lot of news. And a lot of people have been captured and really inspired by a lot of the news and breakthroughs that have been happening in accelerated AI and cognitive computing. But the reality is that this is simply the latest workload that we're seeing of a long line of workloads on this path that we've been following for probably over 10 years now for accelerated computing. And at the very beginning, it started with relatively small communities of researchers and developers that were targeting these domains, and they're making these fantastic breakthroughs. But these breakthroughs were, at the beginning, relevant to kind of these narrow spaces for like physics or chemistry and all kinds of other areas. The difference nowadays, though, with accelerated AI and with cognitive computing is that suddenly now all of these accelerated workloads are relevant to everybody. These kinds of technologies are affecting major sectors of our economy now, and they're not just small impacts. They're hitting sectors like manufacturing, energy production, and transportation and distribution, transportation and healthcare. These are all sectors that touch our lives every single day, and they're really potentially, the potential here for transformative impact for these workloads is really tremendous. I think I'm expecting to see a lot of really, really strong and really transformative impacts with these latest workloads. And I think it's actually just the latest in a long series of workloads that we're seeing that benefit from these types of architectures. So I'm really looking forward to the future, and I think this is going to be a really exciting time for us.
Thank you, Jerry. So you know, I was thinking, as you were saying it, talking about it, that what you're really saying is I think two things, right? One, you got your AI workload. This is going to touch everybody. And then, oh, by the way, we're going to also pick up lots of new workloads and accelerate those in the future as well. So what do you think the role is of these advanced system architectures, like I said, in the ability of accelerators to address more workloads? Because that's going to be the trick, obviously, in the industry, is get accelerators to touch more and more workloads.
Yeah, absolutely, absolutely. So as many of you know that are in this space, the fuel that feeds a lot of these cognitive workloads ultimately is the ability to ingest huge amounts of data and then be able to compute on that data across large systems, large pieces of infrastructure. And a lot of the breakthroughs that we've seen today really are at the node level, and these are achieving some fantastic breakthroughs, especially with these great systems that we're seeing now with lots of GPUs and lots of bandwidth in the system. But I think the next big step, given that there's so much data coming in now and the computational workloads are getting bigger and bigger and bigger, the next big step is the ability to be able to spread these computations across clusters of systems, where the kinds of technologies that we're talking about here with high bandwidth interconnects between multiple systems, each node's being highly accelerated, is going to be fantastic. And that's going to be the next stage of evolution that we're going to see.
All right, Jerry. Well, great. Thanks a lot. And I appreciate you coming up here to join me.
Thanks very much. It was a pleasure.
Yep. OK. So throw the last chart up there. You can't do an OpenPOWER meeting if we don't at least throw the roadmap up. Actually, this roadmap chart doesn't look that different than the last one, which is always a good thing. We have a lot of consistency in the roadmap. But the one thing, again, that I always like to point out with this chart, and I'm going to reiterate it here, is if you go and you look at everything prior to Power 8, actually we dropped off Power 6, so I guess to the left there, but you can still see, Power 7, Power 7 Plus, Power 8, every chip was in a different technology node. Technology was the driver. You go forward, right, and you can see it if you look carefully at the chart. You can see it that now all of the innovation and what's happening in these roadmaps is all about advanced I/O and signaling and connectivity. That's where the performance is coming from. That's where the value is being generated again, which is consistent with what I've been telling you. And I think that's a very, very important piece as you look to the future and you look at what we're doing with OpenPOWER, what we're enabling our OpenPOWER ecosystem to do, and then ultimately what we're going to enable you guys to do to create new and creative solutions for your clients and your use cases. So with that, I'm going to wrap up and thank you very, very much. Appreciate you all's attention. It's always great to get a chance to share with you what we're seeing and what we're doing here at IBM, as well as I appreciate all of your all's involvement in OpenPOWER and your participation in that ecosystem with us. So thank you very much.